Kia ora, Year 12 and Year 11. This is question 3A, B and C from last year's school algebra exam. So this first one's an achieved question and then a couple of merit questions. So here's question 3A. How many roots does this curve have? So you don't have to find what they are, you just have to say how many they are. So that's a different way of asking about the discriminant. So let's work out b squared minus 4ac. Well, we've got a is equal to 6, b is equal to -4, and c is equal to -3. So b squared minus 4ac is important because if it's positive, there'll be 2 roots. If it's 0, there'll be 1 root, 1 repeated root, and if it's negative, there'll be no roots. So the first bit, b squared, so -4 squared minus 4 times 6 times -3. So that equals 16 plus 4 times 18 gives me 72. So that's equal to 88, which is strictly positive. Therefore, the curve has 2 real roots. Right, next question. We have to simplify this expression, and you can see that it's got a surd in it, which is a square rooty sign, and it's got a negative power. So there are different ways to go here, but probably the easiest thing to do is to take this -2 and realise that that means that that's the same as 18b over a to the power of 4 root 9b to the power of 4 squared, right? Because negative powers means you're working with reciprocals. I'm going to now simplify the thing under the square root sign. So as usual, there are lots of ways to do these questions. This is just one way, but a to the power of 4, right, the square root of 9 is 3, and the square root of b to the power of 4 is b squared. So that leaves me with, and that whole thing is squared. So working with what's inside the brackets, we've got 6 over b a to the power of 4. So we've got a b here and a b squared here. So that's how come I get the b down here. And that has to be squared. So my final answer here is 36 divided by b squared a to the power of 8. On to the last question for this video. This is question 3C. We have to write this as a single fraction. So when we're working with numeric fractions, we have to get a common denominator to be able to add them, and it's exactly the same for algebraic fractions. So that common denominator will be x minus 3 times x plus 2. We had to multiply this by that, so that's what we have to do to the 4x. 4x times x plus 2. Take away 5 times x minus 3. But we don't want to leave it like that. We want to clean that up. So that gives me 4x squared plus 8x minus 5x. Be careful with the 2 negatives, plus 15. And we can leave the denominator in factorized form. That looks fine. Cleaning up the numerator, I'm going to collect up the 2 like terms, 4x squared plus 3x plus 15 over all of this. It's fine if you want to expand out that denominator as well, it doesn't matter. So there you go. So that was a nice merit question, just making sure that you understand how to work with adding fractions when we've got some algebra in them. Thanks for watching.